Question 15. The point charge in the figure below have the following values: Q1, Q2 and Q3. Okay, Q1 and Q2 are positive while Q3 is a negative value. They are arranged on the corner of an equilateral triangle as given in the figure. Okay, the distance between any two charges is given, which is d. Okay, we have to find the magnitude and the direction of the net force acting on the charge 1. Okay, the first charge. Okay, so first of all we see, have the this is an equilateral triangle. The angle is 60 degree. All the three angles are 60 degree. Okay, we know that the sum of the three angle is 180 degree. Okay, okay, so I have draw the diagram for sake of clarity. Okay, first of all we have to indicate the direction of the forces due to second charge Q2 and the third charge, okay, Q3. As Q2 is positive, so Q2 will repel Q1 in the direction as I will indicate this in this direction. Okay, the direction exerted by the second charge Q2 will be like that. Okay, I call this force as F12, force exerted on 1 by 2, or you can alternatively you can say that force on 1 due to 2. Okay, similarly the force exerted by the third charge Q3 in the positive x direction, okay, will be, I denote the direction like that, and the notation for this force F13. Okay, I say this force on 1 due to 3, or in other words you can say force on 1 by 2 by 3, sorry. Okay, we have indicated the direction. Now we have to find the magnitude of these F12 and F13 individually. Okay, then we will take their vector sum. Okay, so according to Coulomb law the forces will be, okay, F12 will be K Q1 Q2 divided by d square. Okay, putting the values 9 into 10 power 9, 3 microcoulomb mean 3 into 10 power minus 6, 6 microcoulomb 6.9 microcoulomb means 6 into 10 power minus 6. Okay, okay, I'm not putting the values, I'm not just putting the magnitude. Okay, I'm just giving only the magnitude, the numerical value, not putting the units. Okay, 4.35 10 power minus 2. Okay, a whole square. Calculating this, the magnitude of 1 2 will come out to be 98.46 Newton. Okay, similarly by the same way using Coulomb law we will find F13, which will be K Q1 Q3 divided by d square. Okay, giving the values. Okay, putting the values F13, 9 into 10 power 9 multiplied by Q1 3 microcoulomb, 10 power minus 6 into Q3, which was 0 minus, okay, this was the negative. Okay, 0.89 microcoulomb, 10 power minus 6. okay, dividing by the same distance, the distance is same, 4.35 10 power minus 2 whole square taking, okay, this comes out to be, okay, with a negative sign, 12 point, because the force will be attractive, this is positive, first charge is positive and the second is negative, so it will be negative, okay, the product will be negative, Newton, okay, F13. Okay, we have calculated of the values of F12 and F13. Now, and once again, we from diagram we see that the two forces. One thing I should explain here, that whenever a force is in horizontal direction like that, or force in vertical direction like that, then there is no need to resolve a vector, okay? We resolve vector only in those cases when they are inclined at some angle with respect to x-axis or y-axis. So, F13 is acting along positive x-axis. There is no need to resolve this vector, okay? We have to resolve only the F12, which is acting at some angle, okay, with respect to x-axis and y-axis, okay? So the two component of this force will be, I denote like that, okay, this will be, okay, this will be force. I call this force as, okay, the second component will be in the negative x direction, okay, like that, okay. What is this angle? What will be this angle? Okay, what will be this angle? Can you tell me this angle? What will be this angle? Theta? Well, this was 30 degree. Sorry, this was 60 degree angle. Okay, this was 60. As F13 and this component, okay, this component is downward. Okay, this is perpendicular. So this angle will be 90 degree. Okay, so as we know the total angle from, I will note in black, the total angle, this angle from here to here, this angle, the total angle, I have used a separate color for this purpose. This total is a straight angle, 180 degree. Okay, so 180 degree, 60 degree plus 90 degree, okay, plus this theta angle, okay, this theta angle, I just make it clear, this theta angle plus theta, okay, because 60 plus 90 plus theta will make 180 degree. So theta become from this 150 minus 180 minus 150, so this become 30 degree, okay. So this angle is 30 degree, okay. Okay, so this component, now we can find these two components, f1 f12 f12 sine, this is the perpendicular component, sine 30, which will be equal to f12 was 98.46, okay, multiplied by 1 by 2, because sine 30 degree 1 by 2 or 0.5, okay. So this will become half of this 49.23 Newton. What will be the direction of this force? This is in the negative x direction, okay, in the negative x direction. I call it x dash dir, okay, direction dir for direction, okay. Now what will be this component? This will be equal to f12 cos 30 degree, and it becomes, okay, This component become F1 98.46 multiplied by 0.866. We know that cos 30 is equal to 0.866. This comes out to be, its value comes out to be 85.26 Newton. Okay. And this is along negative, okay, along negative y direction, okay, negative y direction, downward. Okay. So we have calculated. Yes, so we will the in the what is the total if I ask that what is the total force along what is the net force acting on charge 1 along x-axis, net forces along x-axis, okay, then you will say that the total net force along x-axis will be F13, the vector sum of F13 and the vector sum of these force, okay, the vector sum of these force, this, okay, and the vector sum of this F13, because F13 is acting along positive x-axis and this force is acting along negative x-axis. So their vector sum will be like that, okay, that we will add these two vectorially. We will add this vector vectorially, okay. So I call this the total net force F net along negative x-axis, the total force along net force acting along x-axis on charge 1 is equal to 49.23, okay, the greater force minus the lesser force minus 12.7 Newton, okay. This comes out to be 36.53 Newton, okay, okay. This is still, what is the direction of this force? This is still along the negative x-axis because this component is greater than the, okay, because this component is greater than this F13, okay, because it is 49 point something and it is just 12 point something, okay, so the negative direction will be obvious, okay, okay. So this is still in the negative x direction, okay, okay. So it will be better to redraw the diagram and show all the forces, the net forces acting, okay. This is charge Q1, okay. The net force on this charge Q1, okay, one force is that and the other force is in this direction, okay, in this direction. We have find these values. This is 36.53 Newton in the negative x direction and this is 85.26 Newton in the negative y direction. Negative y direction, negative x direction. So this is will be alternatively we can redraw this diagram to make it a closed figure. Okay, it will be better adding these two vector by head to tail rule. Okay, so drawing this will be, this diagram is equivalently we can draw this like that. Okay, just I have displaced this vector there to head to tail rule. Okay, to add this vectorially. Okay, okay. So the resultant vector will be like, this angle will be like that, okay, this will angle will be like that, and this will be the angle which we have to find, okay. So first of all we have to find the magnitude, okay. The magnitude will be equal to, the magnitude of this will be equal to F net, the total net force acting on charge 1, okay, the total net force acting on charge 1 will be like this uh, 30 36.53 square of this plus the square of the other force, which was equal to 85.26, okay, using Pythagoras theorem, okay, and this value comes out to be, obviously this comes out to be, after calculating this, the net force 92.7 Newton, okay. This is the answer of the magnitude. Okay, now we have to find the direction. For direction of force, direction of net force, which will be given by this formula tan inverse, okay, tan inverse, which is the force, okay, 36 point. I call, okay, once again, I have to, it will be better to give some notation, okay. I call this force, okay, I call this force so as this force F net Y, okay. I call this force as F net X. Already I have given a name, F net X, okay. So actually this was F net X square and this is F net Y square we have, okay. I have written it directly, okay. You can do like that, okay. Okay, so what will be, I will write a formula F net Y in net force acting on the along y-axis and the net force divided by the net force along x-axis, okay. This is the very basic formula to find the direction of any vector, okay. So tan inverse, if you do 36 point, okay, this was f net y was equal to, okay, I have made a mistake slightly. Okay, sorry that I have made a mistake here. What was the net force I have denoted here? Okay, this is the 36 point, this is 36.53. This is the net force. Okay, I have made, okay, you have not to make this mistake. We have to see with respect to this angle, okay. We have to see this angle, okay, not like that even the force is acting, but we will check with respect to this angle, okay. So the this is, okay, I have to, okay, I'm sorry for this that I have made this mistake. Many students will make this mistake, okay, so you be careful in this way, okay. This is actually f net y, okay, according to this diagram f net y, and this 85.26 is actually, okay, and this is actually f net x, f net x, okay, because with respect to this triangle, this is the vertical component, okay, this is the vertical component, this is the vertical component, and this is the horizontal component, okay. So putting the value here, okay, okay, f net x, f net y. So f net y is given as, f net y is given as 36.53, okay, it's okay, no, it's okay, 36.53 divided by 85.26, okay, okay, this comes out to be 22.7, 22.7 degree, okay. So this is the direction of the resultant vector, okay, this is the direction of the resultant vector. This angle come out to be how much? 22.7 degree, okay. It almost seems like that, okay. Okay, I hope you will got this answer. This, bye bye.